Assalamualaikum dan salam sejahtera to my lecturer SR Dr. Muzani bin Mustafa. My name is Jusiana binti Junaidi and my other two classmates are Hazila binti Muhammad Arif and Sabiha binti Kamaruddin. Today, we will present our group assignment entitled Linear Programming Techniques. This is a summary of our today's topic. First is an introduction to the linear programming techniques. The second is our project brief and background. Then our three problems that we identified in this project and a conclusion for this topic. Linear programming may be defined as the problem of maximizing or minimizing a linear function which is subjected to linear constraints. The constraints may be equalities or inequalities. Linear programming is considered as an important technique which is used to find the optimum resource utilization. Next, I will brief you about our project background. Our nominated subcontractor is Advanced Infra Sendirian Berhad. It's nominated by Puncak Alam Resources Sendirian Berhad as an employer and Pelangi Seri Alam Development as our main contractor for this project called Construction and Completion of Earthworks Package 2. The contract sum is in Ringgit Malaysia 9,450,000 only and the subcontract period is for 10 months. Our site located at Lot PT 834 Mukim Ijok and PT 1092 Mukim Jeram, Bandar Puncak Alam, Daerah Kuala Selangor, Selangor Darul Ehsan. This is our layout plan. While this is on-site detention pond layout and this is pond outlet and its details. Next, Hazila and Sabiha will brief you in detail about our problem arise on this project. In problem number 1, we solve the contractor's problem in achieving the fastest completion for the construction of mortar riprap at the on-site detention pond. We also managed to estimate the total labor cost required to construct the riprap until completion. If the contractor is more keen on cost saving rather than early completion, we could also calculate using the same linear programming technique by changing the objective function.
A contractor is targeting a cut and fill progress of 10,000 meter cube of earth daily. The contractor is having 12 excavator class A of capacity 500 meter cube daily and 16 excavator class B of capacity 350 meter cube daily, but has only 20 driver available. The cost for A excavator is 850 daily and for excavator B is 600 daily. Now we have to calculate how many excavator of each type should be used for the work for the least possible cost. At first, we have to identify the unknowns. Unknowns X will be how many numbers of excavator A, and unknown Y will be how many numbers of excavator B. Secondly, we have to identify the constraint. For this problem, we have 4 constraints. Number 1 is X plus Y smaller or equal to 15. Number 2, 850X plus 600Y smaller or equivalent to 10,000 meter cube. Number 3, X larger or equal to 0. Number 4, Y larger or equal to 0. Thirdly, we have to identify the objective function. We have 2 objective function here. Number 1 is F equal to 500X plus 350Y and F equal to 850X plus 600Y. After we identify all the unknowns, constraint, and objective function, we can do the solution. From the mathematics solution that we have, we need to plot the graph. From the graph, we can get x equal to 12 and y equal to 3. Therefore, from here, we can conclude that 12 numbers of excavator A and 3 numbers of excavator B should be used for the work for the least possible cost at RM 12,000 daily. Problem number 3. The contractor has to daily dispose surplus earth at least 10,000 meter cube to their own dump area. And the contractor decide to sell the earth surplus with a price of lorry A 250 meter cube for RM 150 and for lorry B 150 meter cube for RM 100. Due to limited resources, the following restriction apply. Authority approval must transport out at least 10 loads but not more than 80 loads per day. Restriction number 2, the number of lorry A must be greater than or equal to lorry B. The number of lorry A must be not more than 10 per day. How many of each lorry should the contractor prepare and sell to maximize their side income per day? And how to maximize an output disposed per day? Firstly, we identify the unknowns, X for lorry A and Y for lorry B. Secondly, identify the constraint. We have 4 constraints here. And thirdly, we have to identify the objective function. From the unknown, constraint, and objective function, we can find the solution for our problem. After we get the result, we have to plot the graph. From the graph, we can get the result of X equal to 20 and Y equal to 70. Therefore, to achieve maximum output per day, the contractor must sell 20 loads lorry A and 70 loads lorry B per day. And finally, the maximum total site income for the contractor is 10,000 per day.
In conclusion, linear programming in project management is utilized to optimize the use of available resources such as material, labor, and machineries. Other than that, this technique is also used to solve transportation and routing problems, or when the most economic product need to be chosen for a construction project. Most importantly, this technique is able to maximize profit or minimize loss when properly applied. That's all for our group video presentation. Thank you and wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.